what we have is white light going through a prism, an equilateral triangle prism, and the rays of light refract on each of the surfaces. You can see the first bending and then the second bending. The combined refraction causes the prism incident ray to be deviated, and the deviated ray forms an image on the screen. You can see the image has got the colors of the rainbow. White light is made up of several colors. Here's a color wheel that's painted in the violet, indigo, blue, green, yellow, orange, and red, 7 equal slices. I'm going to turn the motor on. The colors appear to blend, not quite into white. The apparent bending of a stick when it goes from one medium to another of refractive index is a classic example of refraction. You cannot see it from above, but from the side the stick clearly appears broken, the glass rod that is, and that's refraction. Now let's take a look at the next beaker. It appears that the stick simply disappears. Looking at it sideways, it seems to have disappeared too. What's going on? Well, it turns out that the magic has to do with the resin brand of canola oil, which has a refractive index that's very close to that of Pyrex glass. These large plastic devices are known as polarizers. They are what's found in sunglasses so that you can go out in the sun and not be bothered by reflections of the sun off snow or the lake. Now if I put two polarizers, a polarizer clearly cuts the intensity of light. You can see things that are darker. That's one of the reasons polarizers are used in sunglasses. 50% of the light is lost. The intensity that comes out is 1/2 the intensity that goes in of the electromagnetic radiation. What if I have two polarizers put next to each other? Well, it'll continue to be 50% reduced. The fact that you have two polarizers might make it slightly more, slightly darker, that's all. But observe what happens when I rotate these two polarizers with respect to each other. Complete darkness is achieved, meaning that no light gets through. And then when I rotate it back, all the light comes back through. Half the intensity, that is. This rotation angle is 90 degrees. Polarizers that are at 90 degrees are said to be cross-polarized, and they let no light through.